Guys, so today we are going to talk about scales. Our objectives are going to be determine actual lengths and draw lengths in a scale drawing. We are also going to find the scale of a drawing given the actual lengths and draw lengths. And we're going to talk about enlargement and reduction settings like on a copier machine. All right, so before we begin, I want us to remind ourselves. I want us to write in fraction form this proportion. And remember, the 2:7, remember that's a ratio. So this reads 2 is to 7 as 6 is to 21. So when we write this as a proportion, we get 2 over 7 for the left fraction equals 6 over 21 for the right fraction. So what are the extremes? So this is where we have to remember our definitions. The extremes are 2 and 21. What are the means? Well, the means would be 6 and 7, 7 and 6. Does the product of the extremes equal the product of the means? Well, the product of the extremes is 2 times 21, which is 42, and the product of the means is 7 times 6, which is also 42. So the answer is yes, 42. But we knew that was going to happen because that is a rule. All right, so let's remember how to divide fractions. So for example, if we have 2/3 divided by 50, remember dividing is the same as multiplying by the reciprocal. So this would be 2/3 times 1 over 50, since the reciprocal of 50 is 1 over 50. And that gives us 1 over 75. Let's talk about scale now. The scale for a drawing or a map is the ratio of the drawing's length to the actual length. So for example, if we're looking at a map and we want to know how far away San Marcos is from San Antonio, our map, even though the distance would be 15 miles, the map is not going to be 15 miles long. It might be 1 inch long. And in that case, 1 inch, every 1 inch is 15 miles. Let's talk about a scale drawing. A scale drawing is a drawing in which all of the lengths are at the same scale or ratio to the actual lengths of the object. So let's say San Antonio to San Marcos is 15 miles, and we represent that 15 miles on a scale drawing with 1 inch. Well, if we know that from Austin to San Antonio is 30, we would use 2 inches because it's 15 miles for 1 inch and another 15 miles for a second inch, which gives us 2 inches. So the scale or the ratio stays the same. Okay, so a scale is just a ratio. A scale is just a ratio, and a ratio is just a fraction. So we're dealing with the same types of numbers, we're just putting them in special scenarios. Okay, so let's look at this. 1 inch to 10 feet. 1 inch to 10 feet equals 1 inch to 20 inches, which makes sense because 10 feet, there are 12 inches in a foot, which means that 12 times 10 is 120. Equals 1 over 20. Well, now we have our ratio. So that means that it's 1/120th of the actual size. Let's take a look at an example. Let's say we want to find the length of a bridge in a drawing. So we have a picture, there's a bridge in this picture, and we want to find the length of the bridge in the drawing, and they give us the scale. They say the scale is 1 centimeters to 5 meters. That means every 1 centimeter is actually equal to 5 meters in real life. And they tell us the actual length of the bridge that we're looking at in real life is 27 meters. So we're going to set up a proportion. We're going to let B be equal to the length of the bridge in the drawing, or what we're trying to find out. And when we set up a proportion, the first thing we want to write is the scale that they gave us. The scale is 1 to 5, 1 centimeters to 5 meters, equals, And the second part of the proportion is going to be determined if the first part of the scale is 1 centimeter. That means they're talking about the drawing, which means that the numerator is also, on the second part, is also going to be talking about the drawing. It wants to know the drawing. Well, we don't know the drawing. In fact, we let B be the drawing, right? So that means the second part is real life. 5 meters was in real life. So the second part is in real life. Well, for our question, it's 27 meters. So that's why we put 27 on bottom. So now we solve for B, okay? We can use this using cross multiplying, right? So we get 5 times B is equal to 1 times 27, which is just 27. To solve for B, we're going to divide both sides by 5. So B is equal to 27 divided by 5, which is 5.4 centimeters. And I'm okay with you leaving the answer as 27 over 5. That's fine as long as you reduce. But if you went ahead and divided 27 by 5, you would get 5.4 centimeters, which means that if you're looking at a photograph of a bridge and the scale is 1 centimeters is 5 meters, that your picture, your bridge in the picture is 5.4 centimeters long. Let's take a look at another example. Let's say the distance between 2 towns on a map is 3.6 centimeters. So you're looking at a map. Okay, you've unfolded it, you're looking at it, and one city to another city, you measure it, and it's 3.6 centimeters. The map says that the scale is 2 centimeters to 15 kilometers. So every 2 centimeters actually equals 15 kilometers in real life. We want to know what is the actual in real life distance between those two towns if on the map they're 3.6 centimeters apart. Well, we're going to let n be the actual distance in real life. That's our unknown. Next thing we're going to do is we're going to set up a proportion. First thing on the left-hand side goes our ratio. Our ratio is 2 to 15. So that's what we're going to write on the left-hand side. The next part, the right-hand side, we have to put in our known and our unknown. For our known, we know that the distance between two towns on a map is 3.6. So 3.6 is talking about the map. So we want to put it in the same position as the map is on the scale. For the scale, they're talking about the map in the numerator, which means that we're going to put 3.6 in the numerator too. So that's why 3.6 is in the numerator. And our n, our unknown real life distance, is in the denominator, which is the 15 kilometers, which is also a real life number. Now that we have a proportion, we're going to solve. So 2 times n is equal to 15 times 3.6. 15 times 3.6 is 54. Now to solve for n, we're going to divide both sides by 2. And we figure out that n is equal to 27 kilometers. So in real life, those two cities are 27 kilometers apart. Next example, we have two cities, Carville and Danville, and they are 5 centimeters apart. And our scale is 2 centimeters to 25 kilometers, which means that every 2 centimeters is actually 25 kilometers in real life. So we set up our proportion, 2 over 25 is equal to, now this is our map, right? They're saying it's 5 centimeters apart. Well, centimeters is on top and our scale, which means centimeters needs to be on top for the proportion. So we're going to put the 5 on the top since we're talking about centimeters, divided by n. N is the real life distance in kilometers that we want to find. So that cross multiply, 2n is equal to 5 times 25. 5 times 25 is 125. Solve for n by dividing both sides by 2. And we get n is equal to 62.5 kilometers. So you could have your answer as 125 divided by 2. However, if you were to divide 125 by 2, you would get 62.5. Let's look at a next example. Let's say we want a map and we're going to make this map. We want it to have a scale of 1 inch to 40 miles. We want to know how far apart will two cities appear on the map if in real life they're 55 miles from each other. 55 miles from each other. So we're going to let n be the map distance, right? The distance on the map. First, we have our scale, which they gave us was 1 over 40, right? They gave us that, 1 inch to 40 miles. So if n is map distance is in inches, and inches is on top for our scale, which means that n is going to go on top over 55, right? Because they tell us that in actuality they're 55 miles, and miles is on bottom for our scale. So we get 1 over 40 is equal to n over 55. We'll cross multiply, so we get 40n is equal to 55. Divide both sides by 40 to solve for n, and n is 1 3/8 inch. If you decided to, you could leave it as a fraction, an improper fraction, but you would have to reduce that fraction. You'd have to reduce 55 by 40, which means that you would end up with 11 over 8, I believe. Yes, because you divide both by 5. You get 11 over 8. Next example. Let's say we want to find the scale. Oh, they didn't give us the scale. And they tell us that the two cities are 60 miles apart and appear on a map 3/4 inches apart. So they give us real life and they give us the map. Well, if they give us real life and they give us the map, all we have to do is divide. 3/4 divided by 60. Okay, so this is where we had to remember how to divide rational numbers. Keep, change, flip, or multiply by the reciprocal. So 3/4 divided by 60 would be 3/4 times 1 over 60 because you multiply by the reciprocal, which is 1 over 60. So reducing, 3 goes into 3 once, 3 goes into 60 20 times. That means we get 1 over 80. 1 over 80. And that is our scale. Scale is 1 inch for every 80 miles. Okay, we went backwards. Here we go. Back to P. Here we go. P equals 2. If you add a percent symbol, you have to move your decimal twice to the right. You have to multiply by 100. So 1, 2, giving us 200%. So we've had a 200% enlargement. All right. Next example. Let's say we have a table, and that table of data, right? So we're looking at a table of data. It's 10 centimeters by 16 centimeters. And that's huge, right? Like we don't need a table that big. So we're going to reduce it by 67%. So we're reducing. So what are the dimensions of this new table of data? Well, let's figure it out. First, we're going to multiply 10 by 0.67. Why are we not multiplying by 67? Well, that's because whenever you have a percent, before you multiply, to get rid of the percent, you divide by 100 or move the decimal twice to the left. That's how we got the 0.67. Okay, when we do that, we get 6.7. So 10 centimeters changed to 6.7 centimeters when we multiplied it by 67%. Now the 16 centimeters part of the table, when we multiply that by 0.67, we get 10.7 centimeters. So it reduced from 16 to 10.7. So the new dimensions are 6.7 centimeters by 10.7 centimeters. All right, next example. Let's say that we have a picture in a book is labeled 1 over 30 and an object in the photo is 5 inches wide. How wide is the real object? Well, we have 30 times 5, right? Because we have 30 inches times 5 inches, right? And that gives us 150 inches. However, we need to know what that is in feet, right? So we're going to divide by 12 since there are 12 inches and 1 foot. So we get 12.5 feet wide. So that's how big it is in real life. Next example, we want to find the size of a 3 by 5 inch photo if it is enlarged by 250%. So we took a photo that's 3 by 5 and we made it 250% larger. Remember, we're going to multiply by 250%. However, we have to take away the percent symbol, move it to 2 to the left, or divide by 100. So we're actually going to be multiplying by 2.5. So we end up with 7.5 inches by 12.5 inches. Next example, what should the enlargement of a 3 by 4 photograph be if you wish to place it on a 9-inch by 12-inch paper? Well, so again, how is 3 getting to 9? Well, you had to multiply by 3. How is 4 getting to 12? Oh, you had to multiply by 3. So 3 is what you're multiplying by to get from one to the other. But remember, we want a percent, so we're going to multiply by 100, multiply 3 by 100, or we also say move it to the right twice, your decimal, giving us 300%. So we had 300% enlargement. Well, that's it. That's all I wanted to talk to you about scales. We are going to do a lot of practice problems in class so that way we can master it. If there's something you feel like you don't understand, that's okay because we're going to do some practice problems and we'll work through them so that way you can understand them. And that's where we're going to spend an entire class period doing that. Well, I hope you enjoyed the video. I will see you in class. Y'all take care.